Okay, grade 10s, happy Friday. You are going to absolutely love us because we have given you the easiest work ever for this Friday morning. So sit back, relax, and enjoy. You have one exercise to do. I'm not even uploading a memo for this exercise because it is that simple. You will be able to tell whether you're right and wrong just by looking at the answers at the back of the textbook. It's that straightforward. Okay, so today we are going to you do some calculator work. So you're going to need your calculator. Please make a plan. If you don't have it, it's essential to have one for trigonometry. And the three little buttons we're going to use on the calculator are the sine, cosine, and tangent ratios, and they are right over there. So take out your calculator and see if you can find them for yourself. And then we are going to be given the degree sign. So we're going to be given a size of an angle, and we'll be expected to find the ratio when given that angle. Now remember from the previous lesson, a ratio we normally write as a fraction with a numerator and a denominator, but remember that you can convert a fraction to a decimal, and that's what's expected of us in this exercise. It has asked us to round off our final answers to 2 decimal places. So you just press SD if the calculator gives you a common fraction, and then it will convert it to a decimals for you. So if you take out your calculator and look at sine, if you press the button sine, you'll see it's followed by an open bracket. Then type the number 45 and then press equal. And what do you get? 0.71. It is as easy as that. You type exactly what you see in front of you. So let's try. Cos 2 times 35. You press cos on your calculator and you type 2 times 35. And then I guess it is safer to close your bracket. So put in that right bracket and press equal, and it will equal 0.34. Last but not least, what if the 2 is in front of the cos? Then you just press 2 on your calculator, then press cos, and then type 35. Close the bracket, equals 1.64. It is just something to be aware. It's something that you just need to be aware of, is that when you are given a degree sign, so look at how each question has that little circle as the degree symbol. Our answer is then what we call the ratio. That is the value of the opposite over hypotenuse. If we were in a triangle whose acute angle would be 45 degrees. So if you look at the third example, 2 cos 35, if we're dealing with a triangle with 35 degrees as at a vertex, then adjacent over hypotenuse would give you a trig a value, and if you doubled it, that's why the 2's in front, if you doubled that value, you would get 1.64. So it's just to get, we just want you to get used to using the calculator because you're going to be using it a lot. Right, if x is 43 and y is 24 degrees, determine if the following is true or false. So we need to check if this equation, sine of x plus y, is that equal to sine of x plus sine of y? Can we distribute that sine into a pair of brackets? Well, let's check the left-hand side, LHS, of this equation. That is sine of x plus y. But we've been told that x is 43 and y is 24. So when you whip out your calculator, you press sine, you enter in the brackets 43 plus 24, and close the brackets, press equal, and you will get 0.92 as the value. Let's double check if the right-hand side gives us the exact same thing. If we take the calculator now, we're going to have to close brackets. Apologies, I didn't actually put brackets in that line, but you must press sine 43 bracket, close that bracket, plus sine 24, and then the bracket again, close that bracket, and you will see that the final answer is 1.09. Now 0.92 is not the same as 1.09, so left hand side does not equal right hand side. So if anybody ever tells you that the law of distribution works in trigonometry, you must tell them that is false. You cannot distribute into degrees. We're working with angles here. We're not working with algebra. Anyway, that is that for today. A good 5-minute video. Please go do exercise 5.3 on page 110. Do all of it and have the best weekend ever.